Start the record first. So now we are recording. I will present. Okay, I hope everybody can see the slide. Okay, I really hope that you can see. So today, inshallah, we will learn about the new chapter. So, are you ready? Okay.
Yes.
Okay, good. So inshallah, actually tak banyak. So for this chapter, okay, this is chapter 3, and the title for this chapter is the interpolations. Okay. So in this chapter, there are, I think in the book there are few methods. Okay, there are few methods of interpolation. However, we will cover only two methods. Okay, we will have Lagrange, Newton divided, and piecewise. Okay, so there are three methods. So we only cover two methods for this course. Okay. However, you are able to learn, no problem, for the other methods. So there is a knowledge, so you can learn by yourself, inshallah. Okay, what do you understand about the interpolation? Okay. Okay. So as I said before, they have a Lagrange interpolation, Newton divided difference, and piecewise polynomial approximation. Okay. So only two. We will cover this one and this one. We will cover. This one not covered in this course. So for the goal and objective, so I really hope that after this class, all of you should have a sufficient information to successfully approach a wide variety of engineering problems dealing to approximate the function of fx at a certain value of x in the interval of a and b. Okay, in the certain interpolation, interval. Okay, so the function fx over here is the value of x, the value of y. Okay, we want to find the value of y at certain value of x. Okay, why we want to looking for? Because not enough information in the given problem. Okay, so in general you should have mastered the techniques, have learned to assess their reliability, and are capable of choosing the best method for any particular problem. Okay, for example, we have a graph fx and x, and also we have 4 points. Okay, we have point 1, point 2, point 3, and point 4. Okay, these are known point. Okay, so known point means we have a value of x, we have a value of fx. Okay, however, we want to find the value at a certain value of x. We want to find the value of fx at a certain value of x in between the known value. Okay, this is important. In between the known value. Okay, so known value should be the in between the interval a and b. Okay, so for example, this is the interval a and b. So in between here, so inside the interval, so we can find. So that is called the interpolation. So if the thing is extrapolation, means the outside the interval. So kalau extrapolation. So in since this is interpolation, we want to looking for in between the interval. So we want to look at this point. Okay, we want to find value of fx at this point of x. So this is xk. Okay, this is the value of xk. So By using this method, we are able to find the value of fx. Okay, because ni tak ada graph lah. They don't have the formula. Okay, if you have the formula already, for example fx equal to sin x, so this one no problem lah. Okay, you no need to worry, no need to use this method. Okay, however, you just have the point only. Okay, x1, f1, okay, you have xo, fo, okay, what else, f2, for example lah, f2, and then xn, fn. Okay, only this value are known. Okay, and you want to find the value of fx at the interval of x. Okay, so if this one, if the sin x, so this one no need interval, interpolation lah. No need to use interpolation method lah. Okay, so only for this one, this case lah. Okay, so by using this method, then we can assume like we have the macam seolah-olahnya we have the line lah, we have the formula, for example lah, something like that. Okay, so we want to look at this point. So by using the interpolation, Lagrange, Newton divided or piecewise, and we are able to find the value of fx at the value of xk dia. Okay, so don't worry about the mistakes. Okay, mistakes are proof that you are trying. So please, if you didn't do a mistake, most probably you are not learning well lah. Okay, so that's why we heard things like learn from mistake. Okay, so we go to the Lagrange interpolation. So means that a process of approximating a function fx and estimate the missing function value of the interval. So actually we want to this value actually is estimation, okay, not the precise. Okay, so this is just estimation. So for example, we have 2 points. Okay, so when you want to look at 2 points, so the formula that you need to use, or you only able to use, is the linear point. Okay, you can see this one, for example, they assume this 2 point is the linear. Okay, so this one is regarding with the related with the 3 points, 3 known points. So this one only 2, 0.1, 0.2. So for this case, so 1, 2, 3. So this is the known value. Okay, so for example, this one in the first order, and this one the second order. So you can see the value of p. So p is a polynomial with first order. Okay, and this one polynomial with the second order. So second order, kalau kita ada graph x square, this one related with x only. So for example lah ni, this y equal to x is y equal to, for example example only. So this two is kat sini lah. Okay, second order. So this first order. Okay, so by using this Lagrange interpolation, we can measure at any point. For example, this point or this point, we can measure same to second order, third order and fourth order also. Okay, so this is the general form. Okay, interpolation. Okay, so for the function of fx is estimation or the equivalent to the polynomial of x depend on the number of order, so n, and then summation of Lx times with the Fi. So I think at this point difficult to understand, so later on we can see the details. Okay, where the Li is actually is the, I can say is the macam kecerunan it's like something like that Okay, I think this one should be the last point Okay, so in the Lagrange interpolation polynomial methods, we have 4 degree. So as the first order, okay, linear approximation, and then the quadratic, second order, and then the third order, and also the fourth order. So quadratic, linear, quadratic, cubic, and quartic. Okay, so this is 4 methods that we will cover. Okay, so and this all methods is under the Lagrange interpolation. Okay, let's go to the first order. So as I said before, this interpolation, okay, for the linear, okay, or two given point, or this is two given point. So when it's only 2 points, we assume to be the linear. Okay, alamak, tak linear pula. Okay, what we are assumed to be a linear connection. I can say a linear connection between the 2 points. Okay, so these 2 points become the Astaghfirullahaladzim. Tangan ni. Aduh. Sekejap sorry. My mistake. Sekolah tak edit ke tak tahu. Okay. So this is the this is the value of x1. So f1, so fx1 lah. Okay, this is fx2. Boleh lah, faham lah. So this is the x2 lah. Okay, we want to look at this. At ada, tak kisahlah dekat mana-mana pun. At any given point For example, we want to look at this point. Okay. So this is the xk. Okay, the value that we want to look for, and this is what we want to find. So f xk. Okay. Oh, hilang. Okay. So by using actually the given equation is like this Okay. Ini sebenarnya macam keliru sikit sebab saya tulis I think better I write So the first order, okay. So we saw before the fx1, the fx, okay, is equal to approximate the polynomial of first order. So since this is only 2 points, so first order, and we must have the Lx times with the Fo plus the L1 Fx, so F1, okay, times with the F1. So if you can see from here, 2 points means 2 component. 2 component on the formula. So this is the one component and this is the other component. Okay, another one component. So only 2 component. So please remember this one. So this is the component at the first point. Okay, so kalau saya tulis ni fxo, so this is f1 Okay, saya silap saya tulis. So this is at this point, and the other one is at the second point. Okay. So what actually inside the first point? Okay, at the first point, the L is equal to actually the value of x that we want to look for minus with the x1, okay, divided with the xo minus x1, okay, times with the fo plus x that we want to look for minus with xo divided by x1 minus xo, okay, times with f1. Okay, so this is for the px lah, so ataupun fx lah, okay, fx yang kita nak cari. Okay, at this point if you can see, so at the first component we need to see the value of x over here. So the value of x that we want to look for minus with the value of x1. Okay, so kalau tak ingat, you boleh tengok je lah susunan dia dengan bawah ni ya. So x what we are looking for, okay, minus with x1 divided with xo minus x1. So ni macam ada dia punya relation lah. So for easy to remember, okay, and this one times with fo. So untuk di atas there is no xo. If times with fo, so fo is fxo, okay, fxo, okay, so fxo kalau times with fxo at the numerator, bahagian yang atas ni dia tak ada, there is no xo, okay, so tu senang lah nak faham sikit lah. So then at the second component, so the value of x minus with the xo, so ni fx1, okay, so kita boleh tengok kat sini lah. So at the upside, okay, the above side, so there is no x1, okay, so then the below side is x1 minus with the xo. So sama lah macam ni So this point, so this thing is this part is the LO, okay, and this point is the L1x, okay. So boleh faham tak kat sini? So do you understand? Boleh faham? Boleh faham Okay, so later on in the, I think during the example will be more clear. Okay, yang ni saya dah tulis dah tadi kan. So kalau nak tengok balik boleh lah, tak ada masalah. Okay, so over there is a calculator tips so boleh tengok lah nanti. Okay, now for the quadratic approximation. So when we say about the quadratic approximation, this one, what we must have actually is the at least 3 points. Okay, so 3 points So we need to have 3 points, then we can use the quadratic approximation. Okay, if only 2, so we use the linear. So if 3 points given, so better we use the quadratic approximation. Okay, so since you have 3 points, means that you should have 3 components. Okay, 3 components. Okay, so just now 2 components, so this one is 3 components. So the same equation, similar equation, but have them a little bit change. Ataupun ada information tu perlu tambah sikit lah, additional information. So for example, now is fx is equivalent to polynomial the second order, fx equal to the L0 times with fx0 okay, plus L1 f multiply with fx1 plus with L2 multiply with fx2. Okay, so the difference over here, okay, is only the only at the number of components. Okay, 3 points, 3 components, 2 points, 2 components. Okay, and then the other side actually is the difference at the L1. Okay, the L lah, at the L part. Okay, so the L actually is called they just say L lah. Okay, the L part also become a little bit changed. Okay, so but still the same method. So for example LO, so LO we multiply the value of x minus with the none of nama yang apa, the number that no at the fx. Okay, so kat sini adalah fx 0. Okay, so other than fx 0, so this one is x1, x minus x1, and then times with x minus x2. Okay, then multiply with f x0, and then divide by x0 divide x1, and then x0 divide by x2. Okay, so you can see the relation over here. So ada x2 juga. So x0 minus x1, x0 minus x2. Okay, so at the upside, the above side, there is no fx excluding in the fx. Okay, not only that, so we need to add the other components. So L1 is the same, x minus xo times x minus x2. Okay, divided by x1 minus xo, x1 minus x2, multiply with fx1. Okay, plus with x minus x0, x minus x1, divided by x2 minus x0, x minus x1, times with fx2. Alamat tak muat. Okay, so this is the 3 components for the quadratic approximation. Okay, so ini dah. So saya cuba padam so untuk tengok formula yang dibagi ni. Okay, so ada 3 components, there are 3 components, and then value of x, and then minus of x1 times with x2 x minus x2, and then divided with xo minus x1, xo minus. So kita boleh tengok lah. So this is the relation supaya we are easy to remember So x1, so ada related. So tak perlu fikir pun dah. What is the value you need to add to times or to minus. Okay, no need to remember so much Okay, so atas tak ada pun, there is no xo. Okay, there is no xo. Okay, similar to over here. So there is no x1 at the above side. Okay, so there is also no x2 at the above side of the third component. Okay, so if you can see here, there are a lot of link. Okay, ada link kat bawah ni. Okay, so you can watch the video if you want to study more. Okay, so the calculator tip also included in the slide. So what do you expect with the cubic approximation? Siapa yang boleh jawab for the cubic approximation? What do you expect? So you have a C see or you saw two methods. Okay, for the cubics, what do you expect?
4 points. 4 points.
4 points. Then
Sama method.
okay, yeah, method of course the same. Okay, of course method will the same. So for the cubic approximation, there will be, you must know 4 points. So as the graph, the estimation graph is approximate to pass through all the given points. Okay, 4 points means 4 components. 4 components. Okay, so similar. So kalau saya tulis tu memang panjang lah. So dia akan jadi F, tak antik pula kat sini. So dia ada F, X equivalent to P 3X similar to equal to F X0 plus L1 F1 plus L2 L2 F2 plus L3 F3. Okay, so even though there are 4 components, the value is started with 0, the number 0. So that's why there's only 3. So 0 to 3 is 4. Okay, so for the L, so dia punya formula dia akan jadi lebih panjang lah. Okay, so please remember that there is should be no x0. Okay, x minus x2, x minus x3. Okay, because we have only until 3, so up to 3. And then x minus xo minus x1, xo minus x2, xo minus x3. Okay, so for the first component. And then for the second component, x minus x0, x minus x2, x minus x3. Okay, so then x1 minus xo, x1 minus x2, then x1 minus x3. Okay, times with f1. Then plus with x, the third component, which is the L2. So x, xo, then x minus x1, x minus x3. Okay, ni formula dia lah. Kalau saya tulis panjang memang akan jadi panjang lah. Okay, so f0 x, this is x3, x3 minus x1, x3, x2 x2, wait. Okay, this is x2 actually. x2, x1, then x2 minus x3 times with f2 plus x minus x0, x minus x1, x minus x2. Okay, divided with x3 minus x0, x3 minus x1, x3 minus x2. Okay, don't worry about the value which is larger or lesser, because don't worry about the become negative. Okay, just follow the formula, insyaAllah we get the answer. Okay, so kalau kita tulis, kita tengok formula memang akan dapat balik lah. So I think tak payahlah saya nak dibalik, memang akan jadi sama lah. Macam mana nak angkat ni? Okay, boleh. Lagi senang. Okay, so there are 4 points. Oh, ni dah terlebih ni. Okay, component 1, component 2, component 3 and component 4. Okay, so kita tengok for first component, there is no XO. So kalau you have 4 components, 5 components or 6 components, So you kena darab lah setiap komponen tu punya perkali ni. So you have four components, so at least atas ada this for the L, so at least you have 3 lah. Okay, and then kalau nak ingat 4, so dia 4 mean 1, 2, 3 and 4 lah komponen. Okay, so lagi senang sikit lah. Okay, nanti kita tengok contoh lagi baik lah. Sebelum tu we go for the quadratic. Okay, which is 4 order lah. So bila 4 order kita kena ada 5 given points lah. Okay, when there are 5 given points, we should look at they should have 5 components. Okay, 5 components. Okay, so this is the value lah. So first component, second, third, fourth and we go 5. Okay, so 0 to 4 is 5 lah. Okay, you can see at the first component, which is the value of x minus with x1 times with x minus x2 times with x minus x3 times with x minus x4. So there is no xo lah kat sini. So no xo, so fo ada dekat sebelah dia lah. So time with fo. Dan dekat bawah tu dia start with the xo. So xo minus x1. So kita tengoklah senang kat sini. Okay, xo minus, kita kadang-kadang lupa dia nak tolak dengan apa kan, nak minus dengan apa. Okay, x minus x2, x minus xo minus x3, xo minus x4. So begitu juga dengan seterusnya. So kita ada 4 komponen, ada 5 komponen. 5 komponen. So untuk setiap komponen tu di bahagian atas akan dikecualikan daripada nilai yang nombor komponen tersebut. Okay. Okay, so saya rasa kita tengok contoh lah, lagi mudah lah. So this is the list of calculator tips. Okay, so for your information, if you have 2 calculator, so will be much more easier. Okay, so this for the first calculator you use for another calculation and the other for the formula, for example. Okay, so for the example 4.1, okay, actually 3.1, okay, 4.1. So given the following data, which is then generated by the given function. Okay, so when we have the formula, okay, you can see from here, this example they give you the function. Okay, so where you have the equation. So when you have the equation, actually you don't need to find the estimation. Just enter the value of x, you can get the value of y. Okay, however, this point, when they give you the real function, they want you to estimate, not estimate, verify your calculation with the given function. Okay, so later on we need to compare with this one. So approximate f 4.5 by using linear quadratic cubic quadratic Lagrange interpolation. Find the absolute error for each approximation. So they let you know. So find the absolute error. So once you get the value, so error apa nama ni? I think measured minus with the function. Okay, absolute dia punya ni lah, measured minus with the real. Okay, so real is from here lah. Okay, from here, so measured is from the dia punya kita punya calculation lah. Okay, so I think better I open the Windows first. Okay, wait aish. Okay, so this is the table. Alamak. Okay, everybody can see? I really hope that you can see, everybody can see. So this is the example. Example 1 senang kata. So they ask us to find the value of fx, okay, f 4.5, okay, so y equal to 1 over x, okay. So they ask us to find the linear, quadratic, cubic and Lagrange interpolation, quadratic. So they ask us to find using all the methods, okay. So let's try with the linear one. So try with the linear approximation. Try the first one. So as we know that linear, we have fx equal to p1x equal to LO FO plus L1 F1. Okay, they have two components because linear pass through the 2 points. So 4.5, where is the 4.5 at the table? So if you can see from here, 4.5 is somewhere here. Okay, 4.5. Okay, so then we only take this part only, these 2 points only. So we only take this part, x and then fx. So only this part we take. Okay, 0.25, 5, 0.2. Okay, only this. Okay. So once we take off the points, okay, the others we forget. Okay, and then try to settle to find the value. Okay, so P1 4.5 is equal to, so remember the formula, and the value of x that we want to look for is the 4.5. So 4.5 minus the x1. Okay, so this one become xo, this one become x1. Okay, so you need to remember, and this one become f0 and this one become x1. Okay, 4.1 minus x1, so which is the 5. Okay, divided with 4 xo, 4 minus x1, x1 is 5. Okay, times with fo, fo is 0.25. Okay, then plus 4.5 minus xo, which is 4. Okay, and then divided with 5. Okay, divided with the 5 divided by 4 times with 0.2. Okay, it's equivalent to 0.125 plus 0.1, and that's equal to 0.225. Okay, so this is the equivalent P1 4.5. Okay, so please don't stop at here because they ask you to find the absolute error. Okay, so and then you can say that error the error, okay, the error is equivalent to, the measured one is the 0.225, 0.225 minus 1 point, yang ni kita masukkan lah. Okay, so 1.5, so equal to 0.0028. Okay, so and then kita dah siap lah untuk 1 point. Okay, so mesti nak angkat ni pen. Okay. Okay, so now settle for the linear approximation. Okay, so next is they ask us to find using the quadratic. Okay, they ask to use the quadratic. Okay, quadratic approximation. Okay, so please remember where is the 4.5. So 4.5 is somewhere here. So this is 4.5. So quadratic must at least have 3 points. Okay, must have 3 points. So 3 points is from here. Okay, so ni kita tak payah tulis balik lah, kita tulis kat sini je lah. So then we denote that this is x, tak nampak. Then we write that this is x0, x1 and x2. Okay, this is f0, 1 and then f2. Okay, so write down first the equation. So fx equivalent to p2x equivalent to LO FO plus L1 F1 plus L2 F2. Okay, so we have 3 points, so must have 3 components. So then the value of x, the value of for the, sekarang kita nak masukkan lah, okay, ke dalam equation. So kita kena ingat lah LO tu macam mana kan. So sekarang kita nak cari is 4.5. So sama jugalah macam tadi, cuma use the different methods. So 4.5 minus other than XO. So first one is F1 and then 4.5 minus X2 which is the 5. Okay, divided with 3 minus 4, 3 minus 5. Okay, and then FO is 0.3333. Okay, then plus the second row, the second components. Okay, 4.5 minus other than x1. Other than x1 is 4, so other than that is, the first one is 3. Okay, 4.5 minus other than x1, and this one this time is 5. Okay, and then x1 minus xo, x1 minus x2. Okay, and f1 is 0.25. Okay, so this one is the same method, 4 minus 3, 4.5 minus 4 divided by 5 minus 3, 5 minus 4 times with the fx2. Okay, so then apa yang kita dapat adalah, so the value actually is negative 0.0417 plus 0.1875 plus 0.00 0.0 ni. Okay, 0.750 and the total is 0.2208. Okay, this is the estimation P2 4.5. Okay, and don't forget about the error. So the error, absolute error, 0.2208 minus 1 over 4.5 is equivalent to 0.0014. Okay, so this is the value for the quadratic. If you can see from the, if we compare with the linear, which one have the lowest error? So for now we can see that the quadratic have the lower error. Okay, so quadratic for now have the lower error compared to the linear. Okay, so what happen if we use the higher order method? Okay, let's try. Oh alamak, nak kena copy dulu. I think better we copy first the question. Okay, from here what we can see, whatever method we use, please don't get confused with the table. Okay, don't think that this point must be 0, f0, this one x1, this one x2, this one x3, and this one x4. Not necessary. Okay, we choose first the methods, and then we look how many components that the method must have, and then from there we take the take out from the table. Okay, so make sure we take the correct correct points. Okay, so jangan pula 4.5 is here, you take linear 3 to 4, of course tak dapat lah. Okay, this is wrong lah. Okay, so kena pemilihan method pun, pemilihan point pun kena betul. Okay, so now actually they ask us to find using the cubic. Okay, cubic approximation. Okay, so 4.5 is over here, 0.5, and then cubic must have at least 4. So 4 points, this area. Okay, so then we must mention this is XO, X1, X2, X3. Okay, so we ourselves choose the data, and then we set where is the number of the points, the x0 start for. Okay, okay, then the formula fx equivalent to p3x equal to L0 F0 plus L1 F1 plus L2 F2 plus L3 F3. Okay, so then must have 4 components. Okay, so and then we try to settle down. So for LO 4.5 minus sorry, I make a mistake again. Okay, so 0.5 minus the value other than XO. Okay, we are starting from the X1. So 3, 4.5 minus 4, 4.5 minus 5. Okay, divided with 2 minus 3, 2 minus 4, 2 minus, aduh. Okay, sorry. So 2 minus 5. Okay, times with the FXO, which is the 0.5. Okay, so plus, okay, the value of x that we want to find. Okay, and then divide minus with the component of fx yang not from x1, so excluding the x1, so 2 and then 4.5 minus 4, 4.5 minus 5. Okay, so the x1 is 3, 3 minus 2, 3 minus 4, 3 minus 5. Okay, times with 0.3333, okay, plus with the third component, so 4.5 minus 4 minus 2, 4.5 minus 3, 4.5 minus 5 divided with 4 minus 2, 4 minus 3, 4 minus 5 times with 0.25. Okay, so plus with the fourth component, so 4.5 minus 2, 4.5 minus 3, 4.5 minus 4 and 5 minus 2, 5 minus 3, 5 minus 4 times with the fx3, so this is the 0.2. So what we get here actually the 0.0313 minus 0.1042 plus 0.2344 plus 0.0625, okay, and it's equivalent to 0.2240. Okay, this is the 4.5 estimation, okay, effect estimation. Okay, how about the error? Error is equivalent to 0.224 minus 1 over 4.5. Okay, it's equivalent to 0.0018. Okay, so from here we can see that quadratic still has the lower error. Okay, so not necessary the higher order have the correct answer or the closest answer. Okay, so we have another method which is the quadratic. Okay, so cara ni memang agak bit exhausted. Okay, however we must to do that. Okay, please don't skip using I think better not to skip right during your flow. Okay, kertas kerja, jalan kerja tu please don't skip everything. Okay, even though you can use a calculator. Okay, so now is the quadratic quadratic approximation. Okay, so 4.5. Okay, but it's over here, so we must have at least 5 points. Okay, 1 2 3 4 5. Okay, so this is the point. So everything over here. Okay, it's everything. So now we are using the all data, all given data. Okay, so now we are mentioned that this is x1, x2, x3 and x4. Okay, so this is f0, f1, f2, 3, x4. Okay, so yeah, there are a lot of work we need to write. Don't worry. So this is quadratic, so fourth order. Okay, so we must have 4 or 5. 5. They are fourth order, but 5 points. So 5 components. F0 plus L1, F1 plus L2, F2 plus L3, F3 3 plus L4 F4. So a bit exhausted, don't worry. So you need to do. Jangan pernah rasa bosan So first of all, the value of x minus other than x0, okay. So since this is the first component, okay, other than x0 is the starting with x2. So 4.5 minus 3, 4.5 minus 4, then 4.5 minus 5, okay. And then 1 minus 2, 1 minus 3, 1 minus 4, 1 minus 5, okay, times with the fx0, which is the 1, okay, plus the second component 4.5 minus other than x1 starting with f1, so 4.5 minus 3, 4.5 minus 4, 4.5 minus 5, okay. The second component of the x1 is 2, 2 minus 1, 2 minus 3, 2 minus 4, 2 minus 5 times with the 0.5, okay, and then times x, the given x, minus with the third component. Okay, the third component is x2, x2 is 3, other than x3 starting with 1. So 4.5 minus 2, 4.5 minus 4, 4.5 minus 5. Okay, but with 3, 3 minus 1, 3 minus 2, 3 minus 4, 3 minus 5 times 0.3333, okay, so times with that fourth component. So 4.5 minus 1, 4.5 minus 2, 4.5 minus 3, 4.5 minus 5, okay. Then this one is 4 minus 1, 4 minus 2, 4 minus 3, 4 minus 5. So none of the below 4 minus 4, so dah jadi kosong, bila kosong become infinity, okay, 0.25. Okay, and then the last component, which is the fifth component, so 4.5 minus 1, 4.5 minus 2, 4.5 minus 3, 4.5 minus 4, okay, divide by 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4 times with the fx4, this is 0.2. So what we get here is the negative 0.0391 plus 0.1094 minus 0.1823 plus 0.2734 plus 0.0547 equal to 0.2161. Okay, this is f.5 ataupun p4.5. Okay. Okay, the error, okay, we measure over here. So error is 0.2161 minus 1 over 4.5 is equal to 0.0061. Okay, I think this is one of the highest error. Okay, so normally for the research, you are required to find the best method to find the lowest error. Okay, so for now we are using 4 type methods, and then the lowest or the best one to predict to approximate the value of 4.5 is actually we look at the lowest error. So error yang paling rendah sekarang 0.06, and then ni 0.18, 0.1.4. so the quadratic so quadratic is the best method to predict this kind of value to predict the value 4.4 x 4.4. Okay, so any question?
No, sir.
Tak ada.
No.
So boleh faham semua sekali?
Boleh.
So benda ni dia tak susah, tapi dia exhausted. Okay, dia bit exhausted lah. Tapi don't worry, dalam exam normally dia tak adalah suruh. Normally in the exam the question will not ask you to use all the methods. Okay, so don't worry about that. We understand. So if you if you measure the time before, I don't know how long I do for the all methods. So it's unfair for lecturer to ask a student to do for all methods. Okay, so maybe we'll ask you to do for maybe 2 or 3 2, maybe 2 at least. I think at 2 at most 2 Okay, sekejap je. Think dalam slide ada lagi satu contoh ni. Dia dah buka ni. Okay. Okay, so ni dia punya ni lah. Okay, so for the second example so second example a little bit quite different because the value of x now is not like as we know before, which is the 1, 2, 3, 4, 5 kan. So sebelum ni macam terlalu kecil kan. So before we use only 1, 2, 3, 4, 5 kan. So agak senang sikit. So now dia punya jalan kerja ataupun the value of x a little bit different. Okay. So we read first the question. The carbon dioxide emissions are those stemming from the burning of fossil fuel and the manufacture of cement. They include carbon dioxide produced during consumption of solid, liquid and gas fuels and gas flaring. So table 4.2 shows the world carbon dioxide emissions. Okay, the metric per ton per capita. Okay, so they are take from somewhere. The reference over here. Approximate the world carbon dioxide emission in the year 2007 by using Lagrange interpolating polynomial. Okay, they didn't mention what kind of methods. They just asked us to use the Lagrange interpolating polynomial. So I don't know, maybe we can use other one of the methods, either linear, either quadratic, quartic or cubic. Okay, so however I believe for the study, okay, during the study better we use all methods. Okay, so I think dah ada kat sini lah, so better kita start terus lah. Okay, so now let's try using the linear approximation. So for linear approximation on the last, so the 2007 data is over here. So we take only this part. Okay, take this part, kita keluarkan, kita jadikan dia macam ni lah. Kita tulis di XO. So this is XO and this is X1. Okay, and this is FO, this is the F1. Okay. So then we use the formula that are given. Okay, so the value of x, which is 2007 minus 2008, okay, times with the FO, which is the 4.7. So and then the value of XO, 2006 minus 2008, okay, plus with the 2007 minus 2006 divided by 2008 minus 2006. Okay, darab dengan 4.6 ni lah. Okay, and then we get the value. At this moment, we didn't have the equation. Okay, we didn't have the equation. Like before, the question given is 1 over x. Okay, y equal to 1 over x. Okay, so now we don't have, and we don't know which method have the correct answer. Okay, we just do the approximation. Okay, for the quadratic, so kita kena ambil lah 3 tu. Tak boleh pula. Okay, for quadratic, so 2007 is over here. So quadratic at least 3 points. So we need to take this point. Okay, so I mentioned it, this is XO, X1 and X2. So this is XO, F1 and F2. Okay, so don't forget the formula. So I think during the exam we didn't give you every method equation. Okay, we just give you the general equation. Okay, for example the macam ni kita akan bagi yang tadi tu, yang ada ni, ada simbol ni. Okay, and then I equal to yang ni. Kita akan bagi yang ni je lah. Ni nanti J. Okay, kita akan bagi you macam ni je. Kita tak bagi you everything . Okay, so you need to expand. You need to know how to expand. So that's why I mention, kalau you lupa, you tengok je bawah dengan atas ni mesti sama. Okay, bawah dengan atas mesti sama. Okay, so kalau you lupa juga atas ni untuk yang atas, okay, for above equation, you must minus the equation, the value that not in the dia punya component tu lah. Kalau sini first component, so untuk first component tu mesti dia tak boleh tolak dengan component tersebut. Okay, dia tak ada dekat atas tu. First component tu berada di bawah ni. Ni first component. Okay, so kalau second component, yang atas tak ada second. Okay, so begitulah seterusnya lah. So I think kita pun dah tengok tadi secara detail. So better I think kita tengok satu-satu lah. Okay, so yang ni result dia adalah 4.7. So ni 4.75, 4.76. So tadi ada yang tanya macam mana about the error. Okay, as I mentioned, since the question didn't give the function. Okay, they didn't give the function. Okay, dia tak ada pula, dia kata CO2 equal to 1 over year lah. Tak ada. Dia tak cakap macam tu pula kan. Okay, dia tak bagi pun. Okay, so since dia tak bagi, so mean tak payah buat lah. Dan bukan cakap tak payah buat, tak boleh nak buat pun. Kita nak error dengan apa? Kita nak error dengan real. Real tak ada. Okay, we don't have the real graph. We don't have the real graph equation. So we don't know where to compare. So we just find first. Okay, the estimation. Okay, for example, I give you for example, the COVID number, the COVID-19 case. Okay, so for example, today is 11. So for example, 2, 3, 4, November ni November. I tak tahulah berapa nilai dia katakan sini sekarang ada berapa 800 lah Tak nak ambil tinggi-tinggi, ambil yang rendah je lah. Katakan sini 83. Sini 90, 95 and then this is 100. Okay. And then kita ada sini 7 hari bulan. Okay, then this is 110. Okay, we are missing the 6th of November. Okay, where is the 6th? So we want to estimate lah. Okay, estimate 6 November. Okay, so kita boleh ni lah gunakan method ni untuk kita estimate. Okay, so tak semestinya nilai X ni mesti sebelah-sebelah. Okay, tak semestinya nilai dia mesti ada interval yang tetap. Okay, so this is just estimation lah. So therefore kalau kita tengok di tahun ni 2002, 2003 tak ada, 2004 ada, 2005, 6, 7 tak ada. So 2003 pun kita boleh cari. Okay, kita boleh try tu carilah berapa estimation dia. Okay, so this is the example for the cubic. Okay, so please be remembered that for cubic we must have at least 4. Okay, ada 4. So X0, X1, X2 dengan X3 ya. Okay. So this is the main important thing. So we don't need to use this one this table. We rewrite the table according to the method that asked to do. Okay. So cubic 4 points. Take only 4 points, okay? And please make sure you take at the correct place, okay? So jangan pula you ambil kat tempat lain. So ambil tempat lain nanti jawapan dia akan jadi salah. Okay, so kalau you dah buat guna yang ni, you akan dapat juga 4.75 lah. So sebelah ni pun lebih kurang 4.75, 4.76. So almost the same lah. So kalau quadratic, okay, so for quadratic you take everything take everything okay, so okay, so kalau kita tengok kat sini dia paling rendah lah. Okay, dia dapat paling rendah So I think better we student need to do so that you know where to do, where to choose the data and so on. Okay. Okay. I think I shared already the slide. So now I think better we look at the question. Ada apa-apa soalan?
Tak ada.
Okay, tak ada. So bila tak ada, saya yang ada. Tu bahaya dia. I think saya stop recording dulu. I think saya stop recording lagi baik.